My name is Chase Getz. This is Ben Protzman and Connor Snow, and our team is the Easy Access Door. Throughout this process, the roles of each team member have gradually been added to or refined. As project manager, I've coordinated group meetings, organized timeline and manufacturing schedules. I've done CAD modeling for manufactured components and ANSYS simulation for high heat components. Connor has sourced and ordered our parts and components. He's done electronics and wiring. He's done Arduino programming and created the Bluetooth app. Ben has determined part and motor specifications. He's done ANSYS simulation for failure and applied safety factor relationships and ensured ADA compliance. The purpose of the Easy Access Door is to create a door opening device that is affordable, easy to install, easy to remove without causing damage to the door or doorway, and capable of being remotely operated. The design which was chosen to accomplish this is seen in the two images. This device clamps on the bottom edge of the door and uses a wheel and motors to open the door handle and the door itself.
This device has been designed for use on interior doorways. The main use case of this device is in the world of high turnover housing. For example, buildings with dorm-style living, such as college campuses, retirement homes, or apartment buildings. It would be more economical for the building owners to purchase a few of these units than to allow the use of current commercial units, which are quite expensive. Another use case, which has been recently discovered, is to eliminate the spread of germs and bacteria caused by touching door handles. As stated last semester in the design and fabrication of this device, we strove to follow relevant codes and guidelines, including those of ASME, the IEEE, and ADA. As seen above is our current schedule for our project. All tasks from Senior Design 1 have been completed, including more part analysis and the creation of electronic diagrams. This semester, we have worked on manufacturing and assembling all our components. We currently have a hold on the final steps, which include the fabrication of sheet metal components and the outer case, as we are not able to access the manufacturing lab at this time. With the currently evolving situation of COVID-19, our group has had to transition to individual online work in accordance with recommended social distancing. We have made extensive use of services, including Zoom, Discord, and Google Drive, to make this transition easier. We've also had to move to the self-manufacturing of components when possible.
This semester, we sourced and ordered components with the help of the engineering department. We were also able to have several items donated. There are multiple changes from last semester as better or more accessible parts were located. For example, a more functional Bluetooth module, the HC05, was chosen over the original HM10 module. As can be seen in the updated budget here, the total cost of this project has been roughly $320. This cost is expected to be much lower if parts were ordered in larger quantities as they would be for production. To aid in the analysis of our device, we utilized FEA software. In this case, Fusion 360, to test the displacement of the main housing bracket under maximum loading conditions, as shown in the video. This helped answer design questions such as how will the design fail and what is the device life cycle. These simulations analyzed the components for fatigue, stress, and deformation at different loading conditions to form a safety factor relationship. There are several electronic components within the Easy Access Door device. With this comes a concern that there will be an excess of heat within. To analyze the heat produced by the motor driver at maximum use, we conducted ANSYS heat transfer simulations for the heatsink at the driver ship locations. By running this simulation, we found that the motor driver would not pose any hazard to the device, and as such, could be used.
These are some of the equations which we use to analyze the device for component failure and stresses, and also to calculate the required torque to get the device moving. Shown here are two of the tools which our group used for rapid prototyping. 3D printer allowed for easy testing of bracket designs, while the laser cutter allowed quick testing of bolt spacing patterns.
As development of the prototype progressed, several issues arose with different components. As a result, several changes had to be made in order to ensure proper device functionality. The motor driver was changed to one which interfaced more reliably with the Arduino than the previous motor driver. Another issue concerned the motor used for this device, the NEMA 17 motor. The motor produced an insufficient output torque to open the door. To minimize changes to the device and keep the motor profile constant, we solved the problem by purchasing a geared NEMA 17 motor which stepped up the output torque to the required level. As mentioned previously, we also had to change our Bluetooth module to the HC05 as it provides increased compatibility with MIT App Inventor. Shown here are the specifications of the final device. Several iterations of this assembly were gone through as components were changed and issues were resolved. Note the several zones shown in this figure. The red zone contains the electronics, the green zone contains the motor wheel assembly, the blue contains the handle motor assembly, and the yellow zone contains the batteries.
In order to operate this device remotely, we have created an app using MIT App Inventor. Through this app, the user is able to pair the Easy Access Door device to their phone and open and close the door as desired. This app is available on Android devices and can be downloaded via the displayed QR code. Next steps for our project may include finishing up the manufacturing and assembly if access to the required tools and equipment become available. It may also be beneficial to explore the addition or integration of motion sensors as input options for this device. This would enable use of the device as a general door opener in locations such as hospitals or other medical facilities. This could serve to reduce contact with high traffic surfaces such as doors and door handles. Shown here are the various components of the Easy Access Door. In this area, we have the power source, which in this case is a set of 18650 LiPo batteries. We have the various electronics, which includes a Bluetooth module, an Arduino, and 2 motor drivers. This is the door handle opening assembly, consisting of a NEMA 17 motor and a shaft for spooling up material. And here we have the assembly for the wheel motor, also comprised of a NEMA 17 motor, in this case, however, with a high torque gearbox. And here's an Android device which has downloaded our app. For the purposes of this demonstration, this phone has already been paired to our Bluetooth device. Additionally, pieces of tape have been affixed to the 2 motor shafts in order to better show their rotation. When the open button is pressed, the handle motor begins spinning. Following this, the wheel motor also spins. In order to close the door, button is pressed again. More operations can continue with the handle motor, and the door motor can also operate.
Thank you for your time. This is the Easy Access Door. Feel free to reach out with any questions.